Welcome to Code Coder. Let's start. Ctrl+F.
You're scrolling through a 100-page document, eyes glazing over, hunting for one word. Then you remember. Ctrl+F. You type the word. Half a second later, it's highlighted, glowing yellow, like magic. But it isn't magic. Something specific just happened inside your computer. Here's what's actually going on under the hood. Your document isn't a page to your computer. It's one long line of characters, sitting one after another, like beads on a string. When you type a word into that search box, your computer compares. Think about scanning a crowd photo for one friend's face. You check one face, decide no, move to the next, again and again, until you find the right one. That's roughly how the simplest text search works too. It lines your word up against the start of the document, checking letter by letter. One wrong letter, and it slides forward by one character and tries again. This is called naive search. No tricks, just brute force. Here's where it gets interesting. On a 1,000,000-character document, naive search can perform close to 10 million comparisons in the worst case, for one search. So why does Ctrl+F still feel instant? Because the engineers behind it reached for something smarter, built decades before browsers existed. In 1977, Robert Boyer and J. Moore published an algorithm with a rebellious idea. Instead of comparing your word left to right, start from the right end instead. Picture scanning that crowd photo, but glancing first at one bright clue, like a red jacket. If that detail is missing from a whole section, skip it entirely. That's Boyer-Moore. On a mismatch, it doesn't creep forward one character at a time. It leaps ahead, skipping huge chunks of text that obviously can't match. Around the same time, Donald Knuth, James Morris, and Von Pratt asked a different question. Why does naive search keep rechecking letters it already matched? Say you're searching for level and you've already matched LEV before a mismatch. Naive search throws that away and restarts one position later. But you already know something useful. Those letters reappeared exactly where your partial match ended. The Knuth-Morris-Pratt algorithm builds a small table ahead of time that remembers these overlaps. On a mismatch, it slides forward intelligently instead of starting from zero. Knuth described this kind of analysis as central to understanding algorithms at all. Not just whether something works, but how fast it works as input grows. That question is the entire reason these algorithms exist. Here's the twist most people never consider. You'd assume Ctrl+F works like Google, instantly pulling from some giant index. It doesn't. Google and tools like Elasticsearch build something called an inverted index ahead of time, mapping every word to every place it appears, so a search never scans raw text live. Ctrl+F has no such index. Every time you hit enter, it scans the text in front of you live, character by character, using algorithms like Boyer-Moore and KMP. That's exactly why searching a 500-page PDF feels slower than searching a short email. There's no shortcut database, just the text and the algorithm racing through it in real time. This is also why a classic coding interview question asks you to implement string matching from scratch, sometimes called implement stress. Can you find one string hiding inside another efficiently? It sounds small. It's actually one of the most foundational problems in computer science, sitting quietly behind search bars and editors you use daily. Tools like grep and its faster cousin ripgrep lean on these same ideas to scan entire codebases in milliseconds. Even your editors find and replace run some version of this exact logic every time you hit enter. So next time you press Ctrl+F and watch that word light up in half a second, remember what's really happening. There's no magic and no hidden index waiting for you. There's a 40-year-old idea still racing through your text right now, letter by letter, smarter than you ever gave it credit for.